Well, okay, so R and P is only true if R and P are both true. But this thing is true even if P is false, as long as R is true.
Why can't it reduce this to R, but why can't it also reduce to R and P?
Because this is true even if P is false, but R and P is not true if P is false.
I don't know what's negating P. I think that's the problem. I understand the R, but I don't.
Okay, we need to consider what happens when R is true, what happens when R is false, what happens when P is true, what happens when P is false. Okay, if R is true, this whole expression is true by virtue of the right-hand side. Okay, no matter what P is. If R is false, this expression is false because false and whatever P is still going to be false, and this is still going to be false. So the only way that this expression is true is if R is true, and if R is true, this is true, no matter what P is. Is that, yes, question?
Yes, it has one thing. Is it always assumed that only R is always true? What if it's not R? Is the beginning?
No, if R is false, this whole thing is false.
I understand the innermost expression, not R, right?
Yeah?
What if not R is not false?
Then it's true.
So it's going to give the same.
But we're finding something that's logically equivalent. It's a function of P, Q, and R. So we're finding another function of P, Q, and R that no matter what combination of truth values we plug in for P, Q, and R is going to give us the same answer as the original expression. So it's like, saying we could write something as, x squared minus 1, or we could write it as x plus 1 times x minus 1. Right? They're equivalent. No matter what the value of x is, the left and the right are equal. We're trying to find an expression, so no matter what the values of P, Q, and R are, we get something that's equal to what you'd get if you plug P, Q, and R into this. Okay? All right, so this whole thing evaluates to R. What about this? Q or not Q? True, right? Q has to be true or false. Can't be neither true nor false. If Q is true, this is true because that's true. If Q is false, this is true because that's true. So no matter what, this is true. Okay, so then we're going to negate true. No matter what, that's false. So that's not helping with the or at all, is it? Because anything or false is just whatever the original thing was. Okay? So this whole thing, yeah, this isn't contributing anything. Is the first bit, right? Because it's true only if this is. The other part isn't helping. So what's this? This is not Q or P. Okay. And R. So I'm not sure where the parentheses go here. That's negating this. That's actually negating this piece, isn't it? Okay. So what's the negation of not Q or P? It's not this and not that. Right? So this piece becomes equivalent to Q and not P.
Wait, why not Q and not?
Well, it's already not Q. We're negating the not Q to make it Q. Right? Okay. So we have Q and not P and R. That's the whole thing. So that whole mess reduced to Q and not P and R.